This is All Things ANSYS, a podcast from the technical support staff at PADT. Episode 131, a chat with ANSYS customer PlaneWave about RF simulation and news and events from the world of ANSYS. Greetings, I'm Eric Miller, one of PADT's three owners and your host for these podcasts. Welcome back. Last week, PADT opened our doors for our annual open house and at the same time, a party to celebrate our 30th anniversary. Over 575 people registered, and based on the almost 600 hot dogs of various kinds that we just dished out, I'm thinking around that many showed up. It was great. It was an opportunity for our fantastic employees to show off what they do, from product development to 3D printing, and of course, our ANSYS experts. I just wanted to take a few minutes to thank our employees for putting on such a great event and to speak to our wider audience beyond Arizona who listen to this podcast, especially the ANSYS users. And I want to talk about ANSYS. If ANSYS didn't exist, if they didn't take a chance on a young company 30 years ago, PADT would never have survived. So much of what we are and who we are is because of our relationship with ANSYS. From emails back and forth with developers working on subroutines deep within the solvers to time spent with John Swanson, John Cashman, and Maria Shields, the first time I got good tequila was actually with Peter Smith, the board chair, who took the company public. Most of all, I remember the time with the technical leads like Grama and Dale Ostergaard and Dave Conover and so many others. And then there were the sales kickoffs, where I got to know the sales and marketing people over the years and work with them as ANSYS grew and prospered. Some of them are friends still today. 30 years is a long time, and we could not have spent it with a better partner. ANSYS is so much more than software, and we are proud to have played a small role in their journey and to have them play such a huge role in ours. So anyway, let's focus on the future. And the future is space and, to a large extent, antenna design. We're lucky enough, because everything has an antenna in it now, even in space, and we're lucky enough to be joined by a user from the customer PlaneWave to talk about how they use ANSYS HFSS products to design their antennas for space and aviation. So let's take a listen. Well, thank you, everybody, for joining us today for another conversation. Today, we're lucky enough to be joined by a customer who's going to talk about a very cool application that is literally out of this world. And so I'm pretty excited about it because, we get to talk about some sci-fi kind of things. We're joined today by K1 Bahadori, who is from PlaneWave, and they used ANSYS HFSS with the SBR Plus functionality to model some antenna design. And I'm not going to try and explain it. I'm going to let you go ahead and get started. K1, thank you for joining us.
Thanks, Eric, and thanks for having me on this program. Now,
yeah. Really appreciate it. I also want to point out that Alex Moody, who is one of our application engineers here for high frequency electromagnetics, has joined us today, and he's going to jump in when needed to talk about some of the technical stuff.
Hi, everybody.
Thanks for joining us, Alex. So, K1, why don't you tell us a little bit about yourself and the company PlaneWave?
Sure. Thanks, Eric, again. Thanks for having me on this program. My name is K1 Bahaduri, and I am the co-founder and chief engineer at PlaneWave. PlaneWave is basically a new RF antenna company with the specialty of designing front-end communication hardware for space and aviation applications specifically. And in that domains, we are working on both navigation, communication, and radar applications. Within the team of the company, we all have been around designing and manufacturing these parts for these environments for a good amount of time. Personally, I did my PhD at UCLA on some spaceborne reflector design ideas, and that was when I learned about high frequency and ray tracing based techniques. These are very powerful techniques to simulate and predict the performance of large antennas and basic structures when impinged on or radiated into electromagnetic waves. after UCLA, I joined a company in California working on antennas for aviation applications, especially commercial airliners. And when I went there, I also took myself my knowledge of ANSYS and I started using Ansoft, simulating small and medium-sized antennas, mainly for navigation and communication purposes. Back in 2012, I joined the SpaceX as the first antenna engineer. And prior to my time at the SpaceX was almost completely relying on outsource or outside support for their simulations and analysis, as well as antennas. One of the initial requests that I had from SpaceX is to bring both capabilities, and that's where we started using HFSS. At that point, HFSS was incorporating or start to bringing the hybrid methods. Before that, it was pure FEM simulator, but that was when the first generations of IE simulators were introduced, which we used in simulating larger ground planes. Again, the main challenge and main questions is usually you have the performance of the antenna measured and simulated over either free space or small ground planes. And the question is, how would be the final case when it is mounted on a large scale rocket or a spacecraft? And that is not an easy test to perform by measurements. Prior to that, historically, I know companies and places like JPL used to build mock-ups and perform the measurements, but neither the time nor the cost will allow smaller private companies to do that. And that's where simulation value basically shows and comes to the picture. That's where we started using HFSS. I remember one of the coolest application toward the end that I did reuse the first generations of ANSYS ray tracing technique, which let's call it SPR as the software calls it, was when we were about to land the first Falcon Heavy rocket, where 2 boosters were going to land. And very interesting questions were asked by the operation team is, how can we make sure that the landing radar of one booster does not lock to the other booster? And in addition to some system mitigation, another question was, can I, as the head of the antenna EM team, perform some analysis showing that if the possibility of antenna basically beam and isolation between 2 giant basically rocket landing with some distances would occur. And that's where I remember one of the longest simulations at that time I had to run, but results was promising, and we kind of got a green light and went ahead with the launch. Now at PlaneWave, again, as a startup in the area of space, where we are designing and conceptualizing a lot of initial concepts for other startup companies in the space domain. We occasionally need to perform analysis, concept proof analysis, to show just this novel idea of which sometimes companies are formed based on work, basically. One of the customers we were working on and is involved with the whole lunar explorations, which would be a very active era in the next, I'd say, 5 to 10 years. And challenging questions is communication on the surface of the moon for both vehicle to vehicle or vehicle to basically relays or direct to Earth communications. All of these links with the high bandwidth that is now required by this application is a challenge, especially for the South Pole locations, where for scientific reasons are the highest interest and highest interest point that missions are designed to now. Because of its specific location and the way that Earth would basically rises and sets, you have a very limited and low apparent angle to the Earth. And the question is, we all know that whenever you have a very low horizon communication, the major issue is what is called multipath, when rays are coming very, very parallel to the surface and they get bounced, and this is the classic multipath questions. Another applications where we have this problem is for navigation systems and GNSS applications. When rays are coming very, very on the grazing angles, they can bounce and introduce this issue. To address that, we at the PlaneWave start to looking for some information regarding the surface of the moon. And interestingly, we found that NASA now is publicly providing a very high resolution, up to even, I want to say 5 meter, if I'm not making a mistake, 5 meter resolutions of the surface of the moon, which can be used technically. And I thought that if I have the surface and if I can find a way to import it to SBR, I should be able to simulate these concepts. The SBR module is a very versatile and capable module. It can work with a wide range of antenna inputs. You can have antenna full model simulation results directly imported from ANSYS, or you have options of quote unquote simplifying the antenna pattern and use the concepts, as well as importing just external measured or simulated data. In this specific case, the antenna itself was designed in HFSS, so the problem was simpler. By performing some gymnastics basically between the CAD tools, I was able to convert and simplify the model enough that it keeps the minimum resolution that I need, but it allows me that at the frequency that I was interested. And with this way, I was able to simulate a very large portion of the moon surface that I thought would be of the interest, meaning that after that much distance, we were out of moon curvature, and that is practically the whole line of sight area that a ray can see. And we performed the simulation, and the results were very interesting. By interesting, I mean, first of all, it was matching the intuition and first order calculation. So it kind of gave us, because it's so unique and novel that you don't have any other benchmark to compare to. But when things match with physics and your intuition and calculation, back of the envelope calculation, it kind of gives you a warmer feeling that things are doing okay. Because I have to say that I also part-time teach at UCLA. And I keep telling my students, especially the ones that are about to go out and start using these tools, tools specifically like ANSYS are very very tricky. Some students get these wrong impressions that a powerful tool will, a powerful tool means that I do not need to know, or I do not need to be very careful, and the tool does the job. I keep telling them that it's contrary. So a good output is these tools are not going to replace us, because still you have to have the intuition and physics. Tool is not going to, unless you have some sort of syntax or runtime error, tool would run it and in an iterative base will give you some results. It's up to you as the user to decide and to comprehend and to judge if these results are meaningful, or the physics have been captured, the physics model have been captured, or the resolution is there. That's why it's one of my first kind of homework and task for them is to explain the results that you get. If you can't explain it, then there's a good chance you made a mistake in modeling. Yeah, it's not the tool; it's the user.
It gives the answer we ask it to give us.
Exactly.
Yeah.
And I keep using the term garbage in, garbage out. I say, guys, if you keep on garbage in, the tool is not going to come and complain. It will just run it, but it's us. So the results match. We even did some of once we have the I call it big simulation, we could generate some simpler one, changing the patterns and perform some comparative cases. And the results are very critical because prior to these results, the government office that would review these proposals were very adamant and would require a large double-digit dB margin just to deal with this issue, which will make the system almost impractical or very hard. It would make the designs fewfold more complex to just address this corner case. However, with these results, they could basically lower the margins, make the case much more simpler and more affordable in terms of design and power and size and all that. So this was another examples of now these tools are becoming super useful, super strong and accurate. Another recent appreciation that we have that PlaneWave had is for the last 3 or 4 antenna designs that we did, we went zero iteration, meaning that we built it, we measured it, because prior to that, I can say, I am now using HFSS actively for about 20 years. Mm-hmm. But especially when you're dealing with plastics, and it's not, again, it's the problem of the machine, but it's the modeling. The material characteristics of plastics are not basically measured close enough, and they are usually frequency dependent and shape dependent, that a simple dielectric constant and tangent loss is not enough. That's why my general rule is you go 80%, 20%, you design, you build it, it's going to be off a little bit on frequency, and after the first iteration, it should be there. But by combining the whole information and legacy numbers that we've had, and the accuracy and the strength of the machines, now we've been able to go zero iteration, which is a super valuable capability. It saves time, it saves cost, and it gives customers basically confidence that when we propose using our simulation data, they feel that there is a high likelihood that when they build it, it's going to come within sometimes now half a dB of what we simulate, which is very, very, very useful.
Very handy.
Yes, correct.
Yeah, that's fascinating. So it seems like, my exposure to HFSS is not this SBR plus tool. So, Alex, can you just give us kind of a very high overview of what is SBR plus and why do we recommend it to customers, and when do we recommend it to customers?
Yeah, those are all great questions. So SBR plus is the shooting bouncing ray. It's a ray tracing algorithm. So many of the traditional HFSS solvers like the FEM and the IE solver, they're what we call full wave solvers. So they mesh the geometry in your design at a sub-wavelength level. So if your wavelength is a meter long, it's going to have to mesh all the objects at some fraction of a meter in order to correctly characterize what's happening in the design. SBR plus is a ray tracing solver, and it doesn't need to mesh at the wavelength level. It can mesh just conformally. So long as the mesh conforms to the geometry of the object, that's good enough. It doesn't have to be very fine. And the reason that's important is for something like K1's lunar surface, that lunar surface, if I recall, was on the order of several square kilometers, which can be very large compared to a wavelength. So if you have to perhaps increase your frequency of your transmit array or something like that, well, then the wavelength becomes smaller, and this becomes an electrically very large and intimidating problem, maybe not feasible to solve with some of our other solvers. Whereas with the SBR plus, because it's emitting rays from the antenna, and it's an approximation, but as K1 just pointed out, it's a very accurate approximation in this case. Because it's emitting rays, It can be accelerated by the GPU. So you have the speed up from the GPU. You have it largely frequency independent, at least in terms of the mesh, because it only needs a conformal mesh. And so it's very quick, it's very accurate. And another thing to point out is when it comes to importing in these really large models like this lunar surface, it has an ability called lightweight geometry, where it can bring in the STL file. And typically STL files triangulate your geometry. They create a bunch of triangular meshes. And if you bring that in as a normal STL file, all of the faces and edges of those triangles have to be created and held in memory in HFSS. And it makes it very slow and unresponsive. But if you bring it in as a lightweight STL file, what it does is it smooths out all those triangles and it just represents the geometry as one face. So it's much more quick and responsive, quicker to import, quicker to zoom around with the camera and pan and rotate. So it's faster to simulate. It's faster to actually manipulate the geometry in the tool, and it gives you the accuracy that you need for these multipath simulations. And in fact, you can even visualize the rays bouncing off the lunar geometry, off the lunar surface, and see how they recombine at the receiver. So it's got a really cool visualization feature as well.
That is so make sure I get the scales right here, because that's what I'm trying to get my head around. Is the antenna is how big? It's a meter, 2 meters?
I would guess it's on the orders of meters.
Meters. And the wavelengths are in the meter range, right? And then we're talking about kilometers for the surface. Does the distance between the two objects matter for the simulation, or is that just kind of a given?
Yes, it does. Even in SBR Plus, the distance involved, it's usually measured in terms of wavelengths as well. So you do get a little bit of scaling in SBR Plus for that reason, but the surface itself is not meshed according to the wavelength. So you are free to bring in as big a surface as you like and not have to worry about the mesh scaling with that.
Yeah, that's a big distance, a big surface, wow, okay, that is really, really cool. So, Kwan, what was the biggest challenge you faced in setting this model up? Was it finding geometry, finding material properties? Was it debugging the model?
It was importing the model to that STL format that Alex mentioned. I had to use a third-party software, and even with that, play a little bit. But at the end, again, once it was in, then usually when you're doing a new simulation, and by new simulation I mean a simulation with new sets of settings, I usually try to, first of all, as I call myself professional HFSS user, I force myself to after every new version of it, skim through the softwares and try to get the presentation about the new capabilities and learn them, not in necessarily detail, but I want to have it in the back of my mind, the new capability. So if an application rises, I am aware of such a capability. And then when the time comes, you'll dive, and with the support of great engineers like Alex, let me use my 10 seconds and really thank him. He's been a great help at PADT, super prompt, super accurate, very helpful. I'm really happy. It is a case of good customer service.
Appreciate that.
Yeah,
thank you.
That's a fact. And then you dive into the problem, and when there are issues, a lot of time it happens, right? There are details in terms of formats, clicks, or errors that you get. I work with the PAD team and run it. So for this case, I remember, yes, the bringing the model was a little bit challenging, and then the calibration phase, when you try to play with the setups to get a sense of time versus accuracy, and where they call it knee point. Typically, you have this knee point phenomena in a lot of simulations. By knee point, it's like a diode. Up to some point, by increasing the accuracy or resolution, you don't pay much in terms of time, but after a point, things get the order of magnitude longer, and that's that okay, this is your optimal point, and you want to only go to the other side if you really have to. Sometimes it would be only one last case to just make sure you're super accurate. But other than that, no, it was fine. And as Alex mentioned, we used the GPU, and GPU helped a lot. So I think so far for a good range of large structured capabilities, I think HFSS is really the tool to go to.
That was actually my next question: is any special hardware needed? But it sounds like you ran it on a machine with a GPU and how many cores?
The one that I only use 8 cores. The GPU, and this is a desktop. It's not even a cluster, and it's not fancy. Yeah. At SpaceX, I used to run it on clusters before. Yeah, before the because and the ANSYS tool is mainly used at HFSS with the mechanical and propulsion team. We in the EM and electromagnetics were in minorities and always would get the lower priority. To the point that we went and bought a couple of desktops and just ran it on our machine. But before that, I used to run it on clusters. Yeah.
Yeah, that's impressive. Very good. Wow. This has been really fascinating, really opened my eyes to what can be done. Is this a mission that we can look for in the news soon, or we don't know, or we can't talk about it yet? Is this something we should watch out for?
No, this is a public information that there is a major campaign going on both, and it's not on it's on both sides, meaning that NASA is leading in terms of program management and initiation, all that, but this is mainly done on private sector side, which I personally think that is the right way for different reasons. But basically, we are working with a variety of or a wide range of customers, and I am fairly confident that whoever gets there will be using the tool at some point through their vendors, I call it. Yeah.
Yeah, excellent. Very cool. Yeah. Wow, that is, we'll look forward to that. I always like to bore my friends and relatives. ANSYS was used for that when it comes up in the news. So I will do that in this case. So if somebody listening in is interested in reaching out to your company to help you guys design their next challenging antenna design, what's the best way to get hold of you guys and see what you guys do?
Perfect. Sure. The easiest way is doing it through our websites, www.planewaveinc.com. We have a message box that we kind of actively checking, and we'll be getting back to them. Some of our call it semi-cuts, because the space is so early and in its initial phase that nothing is quote unquote standardized yet to become a commercially off the shelf. Or representative model, you can even find them on websites like SatSearch, which is an international wholesalers for space parts, and LinkedIn, all of the typical professional social networks, as well as our websites. And we'll be very, very prompt and quick in responding to those inquiries.
Excellent. It's a huge amount of expertise you guys bring to the table, and my limited experience in this industry with some of these newer companies is they kind of just assume they can get an antenna that will work, and they probably need to talk to somebody like you as early as possible in the design process to make sure they get the right one. So it's good to know you're out there.
Thanks.
Yeah, great. Alex, do you want to add anything for our listeners before we wrap it up here?
Just to say that if you have interest in SBR Plus, if you want to hear more about the tool or what it might do to help you, feel free to reach out to us. We'd be happy to talk to you about it.
We love to talk about this tool. It's so cool. I'm fascinated by it. I can't wait to see more stuff that we do with it. And communication between the stellar bodies, right? That's pretty cool stuff. So really appreciate your guys' time and hope to maybe talk about a future application when you guys run into one. And as Alex said, do reach out to us if you have any questions. You can reach out to PlaneWave if you have any questions, and get out there and use this tool to make things better and get stronger signals, right? That's the whole point. Yeah. So really appreciate it. Thanks, guys.
Thank you.
Thank you.
Bye. I love hearing from customers. Now, this application was antenna design, but everything we talked about is true for every other physics that ANSYS simulation supports. The development and acquisition of new technologies, the improvements in computational methods, and improved user experiences. It just keeps getting better and better with every release. For today's commercial break, I want to talk about webinars. Although I'd like to think you listen to this podcast because you find my voice so soothing and inspirational. The truth is, we all know you listen to the podcast because you want to learn more about Ansys products and what is going on in the Ansys world. But we just scraped the surface in our interviews. If you want to dig deeper and delve into what is new in the various Ansys products, you should check out our webinars on our website. Yes, we've moved from BrightTalk to our own hosting so we could use Microsoft Teams and for better publishing options. These presentations are given by the same experts we have on the podcast from PADT's Ansys support and consulting teams. We talk about new features or how to use the tools better. It's free, it's easy, and we keep seeing more people subscribe to the channel. So check out PADTinc.com/webinars, and you can see all of the older webinars we moved over and all the new ones. All right, looking on news, looking at the Ansys stock, really nothing special there. I guess if you're a day trader, you can make money off of it. It keeps swinging up and down 2 to 5%. And I guess if you knew what you were doing, you could make money off that. Not me. Right now, it's at 328.41. Over the past 52 weeks, the high has been 364.31 and the low has been 258. So it's had quite a few swings over the last, what is it now? Over 10 months, right? So it's, like I said, it's been going up and down, but it's not anywhere near that price that Synopsys offered of $390 for the acquisition. Speaking of which, no news there, so nothing to report there. Ansys will be releasing their third quarter earnings on November 6th, so we will discuss all of that and their financial results in the next podcast episode. The only Ansys news of significance worth reporting was that TSMC gave Ansys another shout out for excellence. This one was for the tools they have for doing AI, HPC, and photonic silicon systems. So if you don't know, TSMC is one of the big foundry companies. They make chips for other people, and users who design those chips use the Ansys tool set to do things like verify power integrity and find out where voltage drops are, and kind of help with the simulation of the design and verify the design is acceptable. They call it, I think they call it checkout or something like that. That's not the right term, but I'm not an electrical engineer. Anyway, Ansys has been doing a good job in that space for a long time. If you ask me, that's probably why Synopsys is looking at them. And TSMC thought it was such a great job that they did a shout out. Now, the one thing I want to mention that's special about this particular notice, and you can check out the news article to learn more, is that photonic silicon systems. So these are chips that work with photonics and electronics on the same chip. And we're just seeing a lot of new capabilities, new devices that use light as well as electronics. And Ansys is at the forefront of that with their optical products. So check that out. We don't have any news over on the PADT side. Let's take a look at blog posts. I like to recommend 3. So if I go to the Ansys blog, there's a lot of stuff in there. There's a couple articles on digital twins. There's a whole bunch on electronic stuff. But the 3 that I think are worth checking out, in my opinion, are, since the last podcast we had, is one called Improving Product Designs with SysML V2 and Dynamic ROMs Using Ansys Twin Builder Software. It's a really long title, but what it's really about is creating these reduced order models using your Ansys models to use in system level modeling. Really important thing for doing these kind of what we call digital twins, I like to call system level modeling, and creating these virtual prototypes of your whole system, not just a component or a subsystem. So check that out if that's an area you're interested in. Another one that I really like because it hits some cool things is From Simulation to Racetrack, a student-designed hydrogen car. So we love hydrogen cars here at Phoenix. We used to do a lot of work in that space. We love students, and we love Ansys. So putting them all together was great. It was a really cool article and kind of inspiring to read. And speaking of inspiring, the third article I recommend to everybody is called Inspiring Girls to Pursue a Career in STEM. So this is really an article going over all the different things that Ansys is doing to try and help get more girls into STEM careers. And there's some good advice in there, some stuff worth paying attention to. So love all that. Really, really good. All right. On our blog, we've got a couple of things to mention. Speaking of system level modeling, we have an article called Unlocking the Power of MBSE, Model-Based Systems Engineering, a high level overview. And it's a really nice kind of entry level into doing this kind of MBSE simulation. So check that one out. Everybody works in systems. Everybody should know how to model them. Then the next one is exploring the optical design exchange workflow between ANSYS ZMax, Optics Studio, and ANSYS Speos. So this is the way that you can design a lens assembly in ZMax, and then with just a few button pushes, move that lens design over to Speos, where you can do all sorts of ray tracing type simulations, including like stray light and that kind of thing. So big fan of that. Our optical engineers are really happy about that. So customers are really excited about that capability. So worth looking at. And then also in the optics world, our optics engineers have written an article called What's New in Optics for ANSYS 2024 R2. And there's a lot of new stuff in there, and it's summarized by Cynthia in that article. Also, if you want to see what you missed at Nerdtoberfest, check out the post called PADT's 30th Anniversary and 2024 Nerdtoberfest Celebration. And there's a lot of words in there that talk about everybody that was there, but most importantly, if you go to the bottom, you can find the slideshow and see pictures of all of us cavorting in the parking lot and inside PADT. So really cool. All of our blog posts are available at padtinc.com/blog. So the next thing we want to do, the advertising rules for webinars. Well, you might want to be asking what webinars are coming up. Well, we've got the rest of the year booked out. So I don't know. I'm guessing that this will happen after the podcast goes out or before the podcast goes out, but you can still watch the recording. Our next one is on the 30th. It's called Structural Update in ANSYS 2024 R2. This is the second in the series. And this one will look at fracture, linear and nonlinear dynamics, and LS-DYNA. So check that out if you're a structural person. Lots of new stuff in R2. Then on November 14th, our optics update in ANSYS 2024 R2 is going to go over Speos, ZMax, and Lumerical. So all three of the ANSYS product subfamilies, I guess you'd call it, for optics. And our team will go over that as well. Then on the 27th of November, we've got fluid updates in ANSYS, so our CFD users. That's fluid updates in ANSYS 2024 R2, so that'll be on the 27th. And then we'll finish up the year with, I think, our last of 3 structural updates. This is for ANSYS 2024 R2 as well. And this one is on materials, contact, and joint elements in HPC. So again, we've got 4 webinars before the end of the year. Do check those out. You can always watch them live. And so you can ask questions or you can watch the recordings. Just go to padtinc.com/webinars to learn more. The only event we've got scheduled through the end of the year is we are, once again, the award sponsor for the Arizona 2024 Governor's Celebration of Innovation. I have it on good authority that the governor is actually going to be there, along with a bunch of other folks. If you're based in Arizona, I highly recommend. This is the best, well, it's the second best engineering event, technical event in the state in the year. Nerdtoberfest, of course, being the most. But I have a lot of fun there. About the same number of people, about 500 people show up. There's speeches, there's food. It's a really nice event. And it's at Chateau Lux up in North Phoenix, which is a really nice venue. So we recommend you come out and see that on November 13th. And that's what we have for the year. And that's what we have for this episode of the podcast. So once again, we want to thank you. Don't forget to subscribe to our newsletter, www.padtinc.com/opt-in. And don't forget to subscribe to this podcast on whatever podcasting tool you use. So do spread the word, let people know about it. And as always, don't hesitate to reach out. Thank you for joining us for the All Things ANSYS podcast, episode 131. As a reminder, this podcast is not affiliated in any way with ANSYS Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.